This is from this year's AMC12. It is problem 24, which is more difficult than other problems. Now here we are given a 7-sided regular polygon, and we make connections among all the vertices. There are 7 choose 2, that is 21 connections. So we need to find the sum of the first power of those 21 either edges or diagonals. Mark it in color green here. Alright, so there are multiple ways of doing this problem. Sometimes you rely on trigonometry or in combination with geometry, but here I think if you have learned complex numbers and the what is called the nth root of unity, then you're able to solve this problem with your knowledge in complex numbers. So let's go with that approach. Now let's review that. This is the unity circle marked in the blue, and the 7th root of unity here is marked as omega 0 to omega 6. So there are 7 such complex numbers satisfied that z raised to 7th power equal to 1. Alright, so notice that individual value would be expressed in the exponential form would be e, I, and theta. Theta here is 2k pi over 7, of course for k equals 0 to 6. Now notice that for omega 0, that is a real number because angle is 0 here. This is actually a value of 1. Alright, and then you have omega 1. Notice that there are total 7 such numbers, and they add up to 0. Alright, so we're going to use this fact. So why the sum of all the roots equal to 0? Because remember the equation is z raised to 7th power minus 1 equal to 0. Okay, so that's the sum up to 0 here. Notice that those are complex number. Alright, another useful thing you need to know is that omega 0 is 1, so the other non-zero ones add up to negative 1. Okay, now also it's good to know that omega 3 and 4 are complex conjugate of each other, right? So when you add it up, omega 3 plus omega 4, the imaginary part would cancel, and only the real part is going to add up because it's the same value. So here, when you add omega 3 and omega 4, it's going to be a real number, okay? And it's going to be double the real part of individual component. That is, this is the real component here, and this is going to be, for the omega 3 is 6 pi over 7. So that's a real number, okay? That's the summation of these highlighted complex numbers. Now similarly, 2 and 5 are conjugate of each other. So using the same logic, we know that the summation is a real number. In this case, it's going to be this. Okay, and for omega 1 and 6, they're also conjugate of each other. So we have this equation. Now notice that this 6 complex number add up to negative 1, right? Earlier we know that. So now we know that pairwise are equal to each other, and then they just add up to a bunch of cosines, right? So in other words, let's plug in. We have this. So which means, sorry, this is a typo here. This should be negative 1, all right? And then this is negative 1/2. Okay, just remember this is a typo. This should be negative 1. Okay, so that's important fact we're going to rely on later. Okay, so the cosine 2 pi, 4 pi, and 6 pi over 7 add up to negative 1/2. All right, let's go back to the original problem. We try to find the sum of individual lengths and raised to the 4th power. All right, notice that there are 3 types of edges, right? So one is the edge, the other one is diagonal of neighboring nodes, and diagonal, the longer diagonal. So there's 3 types. In other words, when you look at it, the blue, this marked blue lengths are the 3 types, and each occurring 7 times. Okay. Now, what are those in complex numbers? Right. That's the key in solving this problem. All right. So here there are just the difference of omega 1 minus omega 0 and omega 2, omega 3 minus omega 0. So in other words, the sum we're looking for, right, is going to be the modulus length of z1, z2. There's too many typo in this slides. This z2 and this z3, right? So we need to find the 7 of them, right? Sum of squares raised to the 4th power. So that's the quantity we're looking for. Now, how do we find z1, z2, and z4? We just plug in the complex number, right? Just plug in here. Now, zk for k equal to 1 to 3 is just nothing but the difference of this, right? Now, of course, omega 0 is 1, so the real part and the imaginary part. If you take the mod, right, like the zk mod square would equal the real part square plus this square. Now, with some algebra, you know that this is going to be the value. Now, this for k equal 1 to 3. So, these 3 complex numbers. And, of course, we're interested in raised to the 4th power. So, let's just square this equation here. What do we do here? If you square it, you have a square term, right? Now, using the half angle formula here, this can be converted into cosine 4k pi over 7, right? Because this is square. We want to get rid of the quadratic here, right? So further algebra here, you're going to be, this last term is replaced with this 2 term by using the trigonometry half angle formula, all right? Now, I've combined 2 and 4. What you get is this. Now, of course, this is k is equal 1 to 3 for the 3 cases. Now we're ready to calculate the desired sum, right? So s equals 7 of those. Plug in the numbers. Notice that you have 2, 4, and some other 8 and 12, right? So for the 8 and 12, you can convert it into minus 2 pi, other minus 14 over 7. This become negative 6. Yeah, this become negative 2, but the cosine negative is cosine positive. So you can convert this into 2 pi over 7 here, and this one, 12 pi over 7, can be converted into 2 pi over 7. So let's rewrite that. Now here you notice that everything is 2, 4, 6. We combine that, it's going to be 126, and then this is 56 plus 14 with negative 42, and this summation, remember earlier we know that this summation equal negative 1/2, right? So this quantity negative 1/2, just plug in here, and that's gonna be 147, the final value. All right, so in summary, this is choice C, 147, and what we used is actually the basic understanding of complex number, the difference of complex number, the modulus of complex number, and the unity, the 7th root of unity. Yeah, so that's some basic knowledge in complex numbers. All right, this is I think not too difficult, right? So if you are familiar with those topics, all right. So hope you enjoy the video. Please subscribe to the channel.